process the elements using bubble chart? Any idea? Is anyone is ready? Yes, bubble chart. How we did this bubble chart? We taking one element and compare with the next element. Yes, swapping adjacent. Yes, very good, Abhishek. Okay. Taking one element, first element, and compare with the next element. Okay. Like that, we are moving. Comparing an element with adjacent element. If it is greater, swap the element. Yes, very good, Mega. Okay. In the case of bubble chart, we have to take what? How many passes? N minus 1 passes. Okay. Here we are having 5 elements, means we have to go with 4 passes. Okay. In the case of pass 1, at most we can conclude with one element, that is which one is higher, that may be arranged in rightmost side. Okay. This is the way we can do the pass 2, pass 3, pass 4. After the pass 4, we may have the elements will ordered. Okay. Ascending order. Okay. This is the algorithm for that C program and the complexity. This selection sort is nothing but I have I explained with one example, right? The in our schoolings, they may ask the question about writing the elements in ascending order without any formula. Okay, how we can process that? We just taking the smallest element from the list and write that. Okay, and um, leave that particular element which one is selected. Okay, leave that one, and remaining elements, in that remaining elements we select the minimum one and keep. Like that we are doing, right? The same procedure we are doing in selection sort. Okay, the first one is, this is a list of elements given 23, 78, 45, 8, 32, 56. In that, first we assume that the first one is the shorter one. We have to make the list of elements in two types. One is sorted and unsorted. Okay, and in that we have to what? We have to find the smallest one. Okay, the 8 is the smallest one, so we have to swap the element with the first element. So 8 will come to the first position and 23 will come in the eighth where the 8 is placed, that position, that is 3. Okay, like that we have swapped. Now, and this dark line denote the element before the dark line is shorted. Okay, then after, in that in that remaining element we are going to see in next step. Okay, in next step we are going to see these elements only. So in that we have to pick the what? Smallest one, 23. Okay, then we can place the particular 23 in the first element of unsorted list. Okay, this is the unsorted list. Here we are going to swap. Now up to this the elements are sorted. In this remaining element we are going to pick the smallest one, that is 32, going to replace with the what? First element of unsorted list. Okay, like that it's going. After the pass 5 we can get the elements in order. Okay, here we are having how much element is 6 elements, so we can go with n minus 1 passes. Okay. Yes, this is the way again. This with another one example. This is a given array. In that, find minimum element in array of 0 to 4. Not taking the first element. Okay, array of 0 is first element is not taking. In that remaining element, we are going to see the minimum smallest element and replace with it with the first element. Okay, like that it's going. This algorithm for that I explained. In previous class or not, this algorithm have I explained? Students respond me for the selection sort. No. Okay, this algorithm for selection sort. Okay, how we can implement this selection sort? Any idea how we can implement?
We can use two nested for loops, madam. In the
Yes.
outer loop,
Mm. Tell me, pa.
In the outer loop we can select each element, madam, and in the inner loop we'll compare
Hmm.
that compare that element with each elements in the array, madam. If it matches with, if it's greater than the element, we'll swap it, madam. We'll
Okay.
select each element in the array keeping one element, madam.
Hmm. Okay, pa. You please go with your way, okay? This algorithm, you please think in a different way, no problem, and implement with your code, okay? This is the first loop. It is for number of passes, okay? Here I am just as I am declared one variable as min. It is nothing but it having not having value. It is having the index position. I is not nothing but index position. This is here the start with I equal to 0. Okay, the min is 0. Now the min is 0. Okay, like that. It having the value of the index, not a value. Okay. So the second for loop, it is for finding the minimum element. Okay, it may starts from the next element, right? Now here I am having the element min, that is having the index of 0, first position. So I may start with the next position, I plus 1, 0 plus 1, that is 1. Okay, the j loop starts with the element 1 and less than n and j plus plus. Okay, here in that inner loop I'm going to do what? A of j less than A of min. A of j is nothing but second element. Okay. A of min is nothing but the first element. A of 0, this is A of 1. Okay. If the particular element is greater, the first element is greater, need to do what? Min equal to j. Okay, is it clear? Min equal j is nothing but it denoting the second element. Okay, it denoting the second element. The second element is smaller, then we have to keep that particular second element in the, I mean index. Index of the second element we have to store in the min position, min variable. Okay, is it clear? This is the way we are going to implement the particular selection set. Okay, this is the way. The second element is smaller, then we have to keep that particular index in the variable min. Okay, like that we are doing to find the, this loop will iterate up to n number of time to find the smallest element. Okay, after the particular loop is over, we have to swap. How we can swap? A of I is nothing but what? A of I is nothing but the minimum element, the first element. Okay, so the minimum element, the second the minimum element is greater mean, then we have to swap, otherwise we can leave. Okay, this is the algorithm for selection sort. Already I have shown that visualization, right, for the selection sort. Is it so? Yes. Okay. Okay, we will go with the next one. That is, and the time and space complexity for selection set is nothing but order of n square. Okay, order of n square, and space complexity is big of 1. And insertion sort, next one is the insertion start. Okay, this is nothing but it's like playing cards. Have you played cards? All of you, have you played cards? Yes, students. Yes. Yes, how we can play the cards? How we can play? We have list of cards, right? In that we have to pick one card from the list and we keep the particular card in the right position, right? This is the way, right? The same procedure we are going to implement in the insertion sort. Okay, it is like playing a cards. Call the first element of the array is shorted. Okay, we make the first element as a shorted one and repeat until all elements are shorted. Okay, repeat until what are the process we have to repeat? Look at the next unsorted element, insert into the shorted portion by shifting the request number of element. It contains n minus 1 passes. Okay, this is insertion sort. we just making the first element is sorted one, and we have to go with each and search each and every element. Okay, look at the next unsorted element one by one, and insert into the sorted position with the right sorted list with the right position. Okay, where we can keep, for example, see here, and also it contains n minus 1 passes. If the element having if the list having 6 elements means we just go with 5 passes. Okay, see here, first assume that the first element is shorted one, the 5, and compare with the 4. I need to pick one element from the remaining unsorted element, that is 4. We will come up with that visualization. Insertion. See here how the process happening. We pick the 44 and compare with the 3 and arrange based on the order. Okay. Is it clear? Is it clear everyone how they are doing? First you have to pick one element, okay, and compare with the previous element. The picked element is smaller, then we have to keep that position. Otherwise, go to the previous one like that. Okay. See again. 15, it compare with the 47 is, then compare with the 44 is smaller, compare with 38 again smaller, and compare with 5 greater. So we have to keep here. Is it clear everyone how the selection sort will process? Is respond me? Yes. It is like playing cards. Okay. Two. This is number 2. So we have to compare with all the elements which are sorted. Okay. The smallest one, right? So we have to compare with all the elements. Hope you understood the concept. I think so. This is a insertion sort. Okay, this is like playing cards. Okay, so see here now, come with our example. Then element 5 is now assumed as shorted and compare with 4. Okay, I pick the element 4. Next element, I pick the next element, and what compare with the shorted list. Okay, the particular shorted list having only one element, that is 5. I need to compare with 4 and 5. The 4 is smaller, so we have to shift the element 4 in the first position. Okay, before the element 5, and I have to the now my shorter list is having two elements, one is 4 and next one is 5. Now I have to pick the another next element, that is 10. Okay, again I need to make a comparison with the shorted element. First I need to compare with the previous one, then I go with the next one. Okay, this is the way. So how can, yes, once compare with the 5, yes, the 10 is greater, then no need to go with the previous one. Okay, if it is smaller, then only you have to compare with the previous one. Otherwise, the 10 is greater than 5. So I can keep the particular element here because it is a shorted one. So no need to go with the previous one. Okay. So next to pass, I just pick the element 1. I need to compare with the previous one. Okay. Is the position is the one is smaller than 10. So I can't keep here. Another again go with another step also, that is go with the previous one and again comparing. So smaller than 10. So now again I compare with 5 is smaller than 5. Again compare with 4 is smaller than. So I just keep the element here. Okay. And pick the element 6. Again doing the same process. Previous one compare with the previous one is the particular picked element is smaller. So I can come here and check it with the number 5. But here it is greater. The picked element is greater, right? So I can keep the element here. The next position of 5. Okay. Like that I can go with the 2 also. This is the selection sort. Is it clear, everyone? Yes, how we can implement this selection sort? The same way, right? With the help of for loop, we just go with the first element and take adjacent element and compare with it. Okay. Here, but the iteration is happen from the last to friend. Here, right? In this way. So this condition only changed, other than remaining or the same only. So how we can implement? Start with the element 1. Why? Here the first element I assumed as a shorted one. Okay, so I just start with here I equal to 1. Okay, temp equal to a of 5. This is the first element. I mean first element in the unsorted list. Okay, not sorted. The first element is already we have assumed as a shorted one, and the temp equal to a of 5. That is a of 1. Okay, a of 1 is now come to the variable temp. Here we are giving one for loop with j equal to 1. Okay, j equal to 1, and we have to check one condition, that is j greater than 0. No need to take the 0th element, right? Already we have sorted. No need to take that. So here, no need to take that. So we start with the greater than 0 and then temp less than a of j minus 1. Okay. Temp is nothing but the first element. Okay. Temp is having the element first, having the is first element, and it should be less than what? A of j minus 1. J is nothing but what? J equal to same value, that is I. So 1 minus 1, that is 0. A of 0. Particular temp is less than A of 0. If A of 0 is greater, we have to swap. How we can swap? A of j equal to A of j minus 1. Okay. Is it clear? So the temp is having the value of first element, not 0th position. It is having the first element. The particular first element is less than the 0th element. Okay, less than the 0th element. Then we have to do what? A of j equal to A of j minus 1. A of j is nothing but first position. This is 0th position. 0th position is moved to the first position because it is greater. Okay, 0th position, the element whichever in the 0th position is greater, we have to shift to the first position because we are arranging in ascending order, right? So otherwise, if it is not in the case, we just keep the temp as the A of j. Okay, temp, which element is in temp? This first element, I mean first position element, A of 1, which is already in the j, right? So we can just keep the same element, A of j. Okay, this is the way we can implement the selection sort. Is it clear? This is a difference condition. Otherwise, we go with the simple steps only. This is the C program to implement the selection sort. Okay. The next one, time and space complexities are again the same thing. The order of big O of n square. Okay. This space complexity is order of 1. Here they are using the temp variable. So where it may be order of 1. Okay. Particular list is in shorted order, then it is order of n. In generally, we can say that time and space complexity, time complexity is order of n squared only, not we are taking the best case, we just compare and taking the average case only. So for the selection sort, the time complexity is nothing but order of n squared, space complexity is order of 1. Okay. Next algorithm, shell sort. Okay. Generalization. It is a
Ma'am,
generalization.
why space complexity is 1, ma'am?
I have explained yesterday class. No, space complexity
For
is
this
nothing but
case, how, ma'am?
we are just using one variable temp, right?
Yes, ma'am.
It may taking the constant space only. If you are using another one array of storage for replacing the elements, then you go with the order of n. Okay. we
Okay,
just
ma'am. Okay,
we
ma'am.
just having one array and doing some process and storing the values in different array means it may take the spaces order of n. Here we are just taking one constant amount of space only, temp, just storing one
Ma'am,
value.
but that is inside a for loop, no, ma'am. So n should come, no, ma'am.
Even which one come in the for loop?
The temp, ma'am, we are declaring inside a for loop, no, ma'am.
Yes, ma, but we are replacing the temp only, right? We are not storing temp 1, temp 2, not like that. We are just having one space. In that only we are replacing one, once storing one value and replacing with the another value. So no need of more amount of storage. Just we just keep in only one amount. I mean constant amount of time we can say, not for array of elements.
Okay,
Just
ma'am.
replacing with that the single element only, once storing one value and replacing with another value like that. No need to take more space, Ramya.
Okay, ma'am. Thank you, ma'am.
Okay. So next one is cell chart. Okay. In your subject, not deeply in, explained with space complexity. Okay, just to know how their how we can represent the space. Okay, in the case of in many other subject, maybe design and analysis like that only, you may discuss about deeply space complexity. Okay, so the next short is cell short. This is nothing but is a generalization of insertion. We know, right, how we can insertion sort. It is like playing chords. Okay, here also we are doing the same one, but some before that we have to do some steps. We compare elements that are distant apart rather than adjacent. Okay, here we just comparing the element but that are distance apart rather than the adjacent. We are in previous case we are just comparing with the adjacent element. Here we make some is make some gap and compare the elements. Okay, how we can find the gap means this is the formula for n by 2. We just n number of elements, if we have 8 elements, then we can divide by 2, that is 4. Okay, we'll see with the example. Compare element with gap, reduce gap by gap bit, again repeating the process by up to we reaches the 1. Okay, if we having n number of elements, we have to make the gap by n by 2. That means, for example, if the n is 8, then we have to make the gap as 4 and compare the elements in first pass. And next we go with that. Again, this is the n and n by 2, 4 by 2. Again, do the same process, iterate the process. N by 2, that is 2. And again, with the next step, we have to make the gap as 2 and do the process. Okay. Again, the same process, do 2 by 2. And the gap is 1. Until we reach the 1, we have to make this process. Okay. If you are 16, the number of elements is 16, then we go with the 8, 4, 2 and 1. Okay, this is the way we can do this shell sort. In last pass is like insertion. Okay, last pass the gap is 1, so it is like insertion. Again, just arranging the elements. Okay. Shell short is not there. Okay. How we can do? Just make a difference. Okay, we need to find the gap and compare the elements. We will see this example. Here we are having 8 elements. Okay, 33, 35, 33, 42, 10, 14, 19, 27, 24. These are the elements given. We have to find the gap. How we can find? The formula for finding the gap is n by 2. Here we are having the n number of elements, that is 8 elements. Okay, this is n. So we have to find the gap as n by 2, that is 8 by 2 is the 4. Okay, we just divide the particular list of element by the gap value, that is 4 by 4. Okay, here we just divide the particular elements into two. This is the first set and this is the second set. Okay, in that we have to compare the element with first element of both the sets. Okay, you just take 35 and 14 and compare. Okay, in the previous sorting algorithm we just compare with the adjacent elements, right? Here we are finding the gap, and based on the gap we are just comparing the elements. Okay, 35 and 14. Okay, so please compare the 35 and 14. Which one is smaller? 14, right? So we have to swap the elements. If it is not it is already in the form of ascending order, then no problem, we no need to swap. Otherwise we have to swap. We have to pick the first element in the both the sets. Okay, 35 and 14, and compare. The 14 is the second set, the 14 is smaller than the 35, so we have to swap the element. The 14 will come here and 35 will go there. Okay, is it clear? So this is the way we can do. And you please select the second element of both the sets, 33 and 19. Again compare. Okay, the 19 is smaller, right? So we have to swap. 19 will come here and 33 will go there. Okay, the third element, yes, 42 here, 27. Again this is not in the order, so we have to swap both the things. That is 27 here and 42 will go there. Okay, and again the last element, the 10 and 44, the already it is in the order only. 10 is smaller, so no problem, we just keep the element as it is. Okay, this is the way we can do. This is the pass one. After the pass one, the elements be like this. Okay, then next step we have to again reduce the gap 5 by 2, 4 by 2. Okay, 4 by 2 is nothing but 2. So we have to divide the elements, these elements. Now we go with the elements with after the pass one. Okay, divide the elements into with a gap of 2. 4 by 2 equal to 2. Okay, the gap is 4 by 2 equal to 2. So we have to divide the elements which is not from the original, I mean given example, it is element taken for the past 2, the elements taken from the past 1. This is the elements. Okay, so taken that element and divide the elements into 4 parts. Okay, is it clear? Now I need to take what? 4 parts means each part should have 2 elements. Okay, the gap is 2, so I just divide the whole set into 2, 2, 2, like that. So I just take the first element of all the part, all the set. Okay, here in these two, the 14 is the first element, here 27, here 35, here 42. Compare all those things and arrange in the ascending order. Okay, 14, here 27, here 35, here 42. We have to keep all the elements in order. Yes, the 14 is the smallest one. Just keep that in the first place, and 27, 33 and 42. No need to arrange, right? All are in the order only. So we have to keep the elements in the same position. Okay, and then the second element in the set, 19, 10, 33, 44. We have to arrange, right? The 10 is smaller, so we have to keep that as element 10 in the second position and swapping here 19, here 35, here 44. Is it clear how we are doing this cell short? We are finding the gap. Based on the gap, we are dividing the element and pick the element from the different set. We have 4 set. In that we have pick the first element of each set and comparing. Both are having it is made maybe in the order. No problem, we no need to swap. Otherwise we have to swap the element based on the order. Okay, we just keeping the no need to change the position. It is the position of 0, it is 2, this is 4, like that. We have to keep the elements in the same position only, no need to swap. Okay, and now after the pass to, we have the element like this. Okay, and take this the input and doing the next process. The next process is nothing but, now the gap is 2, again divided by 2 divided by 2, that is 1. The gap is nothing but 1. Okay, the gap is 1. So again now I'm going with again with the what, insertion sort. Okay, so far the cell chart is over. With the cell chart we are coming with the insertion. This is called generalization of insertion, right? So now the gap is 1. We need to compare each and every element and swapping. Okay, the same process how we did in insertion. Yes, insertion how we did, select one element and compare with the next element, like that. Okay, so now we go with the insertion. 14 is fixed and compare with the 10 and swapping. Okay, and 27, it is in the order only, compare with the 14. It already what, larger element, so no problem, we just keep it and take the element. Next element is 19 and compare with the 27. It is smaller, so again compare with the 14 is greater, so I can keep the 19 here. Okay, like that you can swap each and every element. Okay, is it clear? We can't find the efficiency. We can't compare the insertion and shell, both are same. Oh, we are doing like that, we can't say. It is for a limited amount of element. Once we go with a larger element, then we can find the difference. Okay, and find the efficiency. Okay, this is the shell chart. I'll go for the shell chart. Just go with, I'll go gap equal to n by 2 and gap should be greater than 1. And next one is how we can do this, incrementing or decrementing with the process of gap. This means that gap equal to gap divided by 2. Okay, gap slash 2 means nothing but gap equal to gap slash 2. Okay, and in that inner for loop, we just start with a gap I equal to gap, and I less than equal, the gap is for first one is the 4, right? We start with it, I less than n, I plus plus, and temp equal to a of I. A of I is nothing but what? A of I is nothing but what? A of 4. Is it clear? This is the gap element I equal to 4. So I can temp equal to a of 4. I check with the condition, the same thing we have did in the insertion. Okay, same thing we are 0, j greater than 0 and temp equal to gap. Okay, j equal to 1 and j greater than or equal to gap, and then temp TMP is nothing but again the same process, TEMP, no problem. Temp less than a of j minus gap. Okay, so temp less than a of j minus 1, compare with the previous one. But we are taking the gap as 4, right? We just comparing the elements with 35 with the 14. So we just go with 0 and a of what, 1 2 3 4, a of 4. So that we are using the variable as gap. Okay, here again j equal to j minus gap. This is the meaning this is the meaning, it means that j equal to j minus 1. j minus gap. Okay, if the condition is true, then we have to what, j minus gap element is come to the jth position. Okay, otherwise until reach, once the condition is, then okay, temp is nothing but which is having the value of 4, a of 4. Okay, this is the way. So okay, based on the gap, now compare formula until reach the 1. Okay, until we reach the gap as 1, we have to repeatedly doing this process. And after once reach the 1, that's how we can, how we did the insertion sort, like that we are going to do after reaching the gap as 1. Okay, so if I divide it into 2 and select the elements in each set and compare, if it is in order, then no need to swap, otherwise we have to swap. After the gap is 1, we just go with the insertion, compare with each and every element and do the process. Okay, this is the algorithm. Start with that outer for loop, for loop taking that variable as gap. How we can find the gap? N by 2. Okay, how we can reduce? Again, gap equal to gap divided by 2. Like that only we can reduce, right? 4 and divided by 2 equal to 2, and 2 divided by 2 equal to 1, like that. In inner for loop, we just giving the variable I equal to 4. We just comparing the 0th element and 4th element, right? And like that. So we are just giving the particular gap starts from the 4. We just comparing the set 1 and set 2. Swapping, otherwise we just keep the temp variable in the aj. Okay, this is a shell start. Next one, this is the program for which we explained here. Okay, the same concept implemented to run the particular program. We just do with all the variables declaration and definition, so no difference. You please go through this and try to run. I will upload have any doubt and ask me. And time and space complexity for best case order of n squared. N log n, if they are using log in the case of time complexity, then it is efficient one. Okay, already told yesterday, right? When we can use the log, once we divide the elements into half and comparing, then we can go with log. Okay, so it is efficient one. The worst case order of n squared. Then average, we can say the time complexity for the particular shell sort is order of n squared. Which one is higher, that only we can take, right? So we can say again go with that order of 1. We just using one variable, that is temp, right? So gap is nothing but it is again used element, the numerical only, so no problem. And if they are using two more variable, the temp and min, temp and temp 1, like that. If we are using the um, variable instant amount of time, then no problem, we can just tell that as a order of 1. If you are using array of elements, okay, then only temp of n. If you are using like that, then only you need to change the spaces to n. Otherwise you can say order of 1. Okay. Okay. Next sorting algorithm in our syllabus is radix sort. Here, how we can do? This is the example, unsorted list. Okay, we are going to sort the element with the help of radix. How we can do? We just find it. We just finding the unit place first. Okay, based on the unit place, we just another name 10 buckets 0 to 9. Okay, for this radix short, how to keep 10 buckets from 0 to 9. We just place the elements in the bucket based on in the first pass. Here how many pass based on the D2D. The first pass we have to consider the unit place. Unit place we know, right? Ones place, 10th, 100th place. This 3, 0, 7. Here 5. Here 1. Here 7. Here 3. Okay, this is the unit place, right? So based on the unit place, we are just put the elements into the bucket 0 to 9. Okay, first element is 43. Where we can place? Yes, where we can place? Please, all of you again, you please, once the class over, you please take the element and uh, implement the sorting algorithm. Okay, you can understand. Just listening is not able to follow. Once, if now it's okay, then after some time you may forget. So please, all of you take the same number of elements and try by your own. Okay, the answer or not. Okay, then only you can able to follow the sorting algorithm. So please here tell me which one. Here the unit place is 3, right? I'm taking the element is 3. So I like this third bucket. And next element is 27. So the unit place is 7. I just keep the I put the particular element in the 7th bucket. Okay, are you following everyone? Students, are you following? Students, are you in the meet? Are you following? All of you respond me. Please post a
Yes,
message.
ma'am.
Yes, ma'am. Who are active? No one in the meet, right? Yes, responded Ramya. Manoj, Megha, Mohit, Rajeshwari, Santosh, Sylvia. Yes, what about others? All are following? Yes, Leela Krishna, Srinivas, Abhishek. Yes, Sharon, Sylvia, Sujita. Yes, Swaminathan, Sandeep, Sanjay, Teja, are you there? Okay. Yes, Pavitra. Okay. So in the case of radic start, we have to first in the first pass we have to. Okay, Santosh. Frequently they are facing network issue, right? Isaac and Yashwin. Okay, in the case of radix chart, we have to find out the unit place first. In the case of path place, that is okay, Ashwin. Uh, Today, no problem. Already you have informed many times, right? That's why it's it. No problem. Okay, here 3. So I can keep the element in the third bucket. Again here 7. So I can keep that particular element in the seventh bucket. And again 31. So I can keep the particular element in the first bucket. And 15. So I go with the fifth bucket. I just seeing the unit place. Based on the unit place, I just put the elements in the bucket. Okay. Again 37. So I come again with the element, what is that, seventh bucket. And 80 means unit place is 0, just keep in the zeroth bucket. And 03, I just keep the elements in the third bucket. Okay, no problem, Yashwin, just I said. Okay, now the elements are arranged in the based on the unit placed. Okay, after the pass one, we have the element like this. And the second pass, we have to concentrate on the 10th place. Okay, for element 80, here see how the elements are getting after the pass one. We have to just write the element from the bucket. Okay, we have to first see the zeroth bucket. Here the element is 80, so I just keep the element here. And 31, in the second bucket we don't have any elements, so just skip that. And in the case of third bucket, we have two elements in the order which are inserted, like that only we can pop out. Okay, so 43 first and 03. Okay, then fourth bucket, no elements. And 15. And here also first we have to take the element from inner, that is 27, again 37. Okay, no need to consider the original list. We just take the list after the pass one. Okay, this is the element. Now my list having this element. Now I'm considering the 10th place and putting the elements based on the 10th place into the bucket. Okay, now I'm having the element as 80. For that, which one is the 10th place? This 8, right? So I can keep that particular element in the 8th bucket. Okay, and 31. So the 10th place is 3. So I keep the element in the third bucket here. And 43, I can keep the element in the fourth bucket here. And 03 means the 10th place is the 0. So I can just keep the element in the 0th bucket. Again 15. What is the 10th place? 1, right? So I can keep here. And 27, I can keep in the second bucket. And 37, I can keep in the third bucket. Okay, so after the 10th place, I have to arrange the element how. From 0th place we can start 03. Okay, so I can pick the element. And 15 and 27. The case of third bucket, we have two elements, so I can start with the first one, that is 31. I have to take the element from inner, right, inner loop. So we can take the element from 31. This is the procedure. We have to keep the element from which is inserted first, right? So 31 is the inserted first, so we can keep that pick the element first from the bucket. So 31. and 37 and 43 and 80. Now the elements are arranged, right? This is the radix sort. Is it clear? If you are having 3 digits, then you have to go with the another one pass. In that pass, we have to concentrate on the 100th place. Okay, we'll go with one example. Same visualization. Radix is there. Okay. Here list of elements are there. Elements having 4 digits. Okay, here 1 digit, 2 digit, anything it may be. In that, in our example, we just having the 2 digit element. All are having the 2 digit. Here, different types of elements are there. Okay. See here how the process is going. See here, bucket is arranged in bottom. First, seeing the unit place, right? See the unit place are marked as red, and based on that the elements are arranged in the bucket. 7. So 7. Okay, see here the elements are arranged into the bucket. Now we have to popped out from the bucket, right? How it happened? See here, from the not from the top, it taken from the list, right? Because it only enter into the list first, enter into the bucket first. 7 and 4127. Okay, now we have to process, we have to concentrate on the 10th place. Okay, here 8, here 2, 3, 2, here no elements, right? I mean one the element is 1. So what is the 10th place for the element 1? What is the 10th place for the element 1? 0. So it may be come to the 0th bucket. Okay, 7 also come to the 0th bucket. Now the bucket is filled. You have to pick the elements into the list. Okay, how we can? 10. We have to pick the elements from the bucket from the least, right? The element which were inserted first, that only picked first. Now check with the 100th place. Okay, place we have to concentrate, and based on that we have to put the elements into the bucket. Here zero. Based on the 100 position, the elements are filled into the bucket. Sorry. Yes, now 100 place is over. We have to arrange the element based on the next position. Here we have 4 digit, so we need to go with the 4 pass. Yes. Now the elements are arranged, right? This is radix sorting. Clear, everyone? If sorting is over, then we have to go with the hashing. Okay. Which are the sorting we have studied in our syllabus in our fifth unit? Which are the sorting we have studied so far? Students, which are the sorting we have studied? I'm asking you. Is radix, shell, bubble, selection is another one, insertion. Okay. Okay, fine. Okay. This algorithm for radix sort. How we can implement the radix? Anyone can explain this concept? We have to find the number of digit. Okay, small uh, logic is what we have to find the number of digit. Okay, based on that we have to go with the passes, right? If we are having 4-digit elements, then we have to go with the 4 passes. Okay, this is the first concept. And inner side means what is the process? We have to find unit place, 10th place, 100th place, like that. For that we are doing one concept, that is div equal to div multiplied by 10. Okay, this is the concept. With the help of this we can find incrementing incrementing the position based on the place, unit place, 10th place, we can insert into the particular bucket. Okay, we have to and in the case of inner loop we have another one concept, that is we have to keep 10 buckets from 0 to 9. Okay, based on that we can insert the elements. Anyone can able to explain this algorithm? Okay, find a larger number in array as large. Okay, this is just logic. Set NOD is number of digit. Okay, NOD is equal to number of digit in large. Okay, so why we are finding the largest element and number of digit in the large means based on this only we are go with the passes, right? If we having 1 minute. 1 minute pa. Okay, NOD is nothing but number of digit. Okay, based on this only NOD only we are going to implement the passes, right? If you have an 4-digit 4-digit element, we have to go with the 4 passes. Okay, div equal, initially we are assigning the div equal to 1, just one variable and assigning into 1. Set pass equal to 1. Initially set pass equal to 1. We need to do what? While loop. Here we are here we are giving while loop up to this, up to NOD number of digit, we have to go with the passes. Okay, in that loop we are just giving that loop equal to 1 to key size. Key size is nothing but what? Here key size is nothing but number of bucket is key size is number of bucket. For example, if it is an numerical value, okay, I just go with the 0 to 10, that is 0 to 9 buckets. 10 bucket, that is 0 to 9. Okay, then for alphabetical, we need to arrange the elements in alphabetical order, then we need to go with 26 bucket, right? 0 to 25. So this is the key size. Based on that we have to keep the key size. Okay. So for element 1 to n, number of elements, how many elements, we have to go through each and every element, right? So this inner loop, in that we just giving bucket number equal to array of element div mod then 10. Mod is nothing but it giving the value of what? Reminder, right? So how we can find the bucket number for the particular element? Array of element, this is nothing but the element in the array. For example, here 43 is the first element, so we have to do what? 43, okay, 43 slash div is nothing but what? We need to keep the same alphabet here, capital, here smaller. We just need to keep in the same way. Okay, so div is equal to 1 for the first pass, and what is the value for that 43 slash 1? 43, right? So mod again with that 43, we just do what? 43 module operation, it give the remainder value, right? Mod 10. So answer is, what is the value? Yes, what is the value for that 43 mod 10?
Sumita ma'am,
Yes, ma'am.
it's already 10:15, madam.
Okay, ma'am. Sorry, ma'am.
Yes, it's okay, ma'am.
Uh, thank you, ma'am. Thank you, students. Thank you, students. I will leave. Suganya, ma'am.
Yes, ma'am.
I will leave, ma'am.